So yesterday we did free response question 6. Today we'll look at a few from, it says free response question 7, but if you look at the packet, there's only two free response questions, and the rest are multiple choice. So it's not exactly free response, but whatever. So we'll do one of the free response, and then we'll do some of the multiple choice. Again, this is due Monday. Don't forget that due Sunday are a video number 6, and the algebra quiz that's in Schoology. All right. Let's read this. This may be important. On the AB exam, horizontal and vertical motion problems are free response questions as well as multiple choice questions. On the BC exam, obviously you're not taking BC exam, but here's a little example of the difference between the two. These questions will likely not be on FRQ section. They'll be tested on multiple choice sections because in BC, basically they cover more advanced motion stuff. And so the basic motion stuff doesn't appear on free response questions for them, but it does for us. And so we can look at number 1 and do that one. Number 2 is similar, so we'll just do number 1. Particle moves along the x-axis. By the way, these are frequently calculator problems. That way you can find derivatives and integrals and slopes and all that stuff in the calculator. And they can give you crazy formulas, and you don't have to worry about taking a derivative by hand because you're going to put it in the calculator. Particle moves along the x-axis with velocity given by this weird-looking function. T is between 0 and 3.5. So less than 0 doesn't matter, more than 3.5 doesn't matter. Before I even go any further, I'm remembering that velocity is derivative of position, and acceleration is derivative of velocity. And that also means I can integrate to go backwards. The particle is at position x equals -5 when t equals 0. So you can make that into like a table, or you could just say x of 0 equals -5, however you want to phrase that. Find the acceleration of the particle at time 3. So how am I going to find the acceleration of the particle at time 3? Take the derivative of velocity and plug in 3. Except I'm not really going to take the derivative. I'm going to let the calculator take the derivative.
Where'd the A come from? Did you just pick there we go, I see it, acceleration.
Find the acceleration, yeah. So, let's see. 10 sine of 0.4 x squared over x squared minus x plus 3. I'm going to go from 0 to 3.5. The y value, I don't really know what's a good thing to pick. So I'll go -10 to 10, and if that doesn't work, I'll change it. Okay. I can see everything, so that's fine. But I think I'd like to see a little more, so I'm going to make it -5 to 5, just to give me a little better picture there for the y value. All right, so I'm looking at velocity. Acceleration would be the slope at t equals 3. Second calc, dy dx at 3 is -2.118. And that's all you have to show on a calculator problem. Like they know that the calculator will do it. So you just say, like what you told the calculator to do, and you're good. And let's see, they didn't have any units on this. It's a little bit surprising to me, but it makes it something we don't have to worry about. Find the position of the particle at time equals 3. Find the position of the particle. Okay, how do I find the position if I have velocity? I need to integrate velocity to find position, but if I'm going to integrate, I need some limits, especially if I'm going to integrate in a calculator. Like, I don't know that I've said this, maybe it's obvious, maybe it's not, but if you're going to use the calculator to integrate, you have to have limits. The calculator can't symbolically integrate. It can't just say that the integral of x is x squared over 2. It doesn't know how to do that. It can only integrate with limits there. So what limits should I use if I'm going to use the calculator to integrate? Yeah, definitely 3, and probably 0, because I know what's happening at time equals 0. So the integral from 0 to 3 of the velocity would be s of 3 minus s of 0. I'm trying to find s of 3. So s of 3 is, if I move s of 0 to the other side, s of 0 plus 0 to 3 v of t dt. And they told us what s of 0 is. So now we just need the integral. So math 9, 0 to 3. I put this in for y1 again, so I don't have to type it all in again. I mean, I could, but that's in for y1, so let's take the easy route here. 0 to 3 is that, and then minus 5. So s of 3 is negative 1.760 meters or feet or miles, we don't know, so don't put a unit on that. At this point, I'm thinking I hope you get a problem like this, because that's pretty straightforward. Part C. Ooh, we talked about this yesterday. Evaluate those two integrals and interpret the meaning of each integral in the context of the problem. What's the difference between those? One's displacement and one's distance. So first job is just evaluate them. So another math 9, 0 to 3.5. So 2.84. That was without 2.844. That was without the absolute value. So what is 2.844 represent? That's the displacement. And you could say total displacement or net displacement, or you could just say displacement. Now, in the context of this problem means we need to say more than just that's the displacement. I mean, you're right, but in the context of this problem means we need to include something about this problem here. Particle moves along the x-axis. So total displacement of the particle during the first 3.5, or we don't know the unit, so we'll just say from 0 to 3.5. I think that would be good enough. I don't think they need you to explain to them that means it's it's right. It's 2.844 to the right of where it started. I think they would have to be more specific if they wanted us to say that. I'm guessing that the main thing they're looking for is distance versus displacement. Again, to me, the easy way to remember that is distance. Distance is always positive. Absolute value is always positive. So that's why we put those absolute value bars on there. Let's see if I can edit this to not have to retype the whole thing. Well, almost. Absolute value bars of y1 dx. Before I hit enter, should this number be greater than or less than or equal to displacement? Probably greater. It might be equal to, but it definitely won't be less than, right? If the particle goes the same direction the whole time, they'll be the same. If it turns around at all, then distance should be greater than displacement. Let's see if that's the case. That way I'll feel better about my answer if I get something bigger than 2.8. 3.7. So I'll buy that. 3.737. Is the total distance traveled by the particle from 0 to 3.5. Again, I'm pretty sure distance versus displacement are the keywords they're looking for there. Okay, I feel like so far so good on this one. We hope we get one like this. ABC were pretty straightforward. D's probably going to be crazy, but we'll see if we can squeak out some points from part D. A second particle moves along the x-axis with position. Okay, so be careful. Position is t squared minus t, also from 0 to 3.5. At what time are the two particles moving with the same velocity? Okay, I have the velocity for the first particle. How do I get the velocity for the second particle? Take a derivative. And I don't have it's with calculator, but I don't really need to take a calculator for this velocity. 2t minus 1. So I see I've got the first one in for y1. I'm going to put this one in for y2. And then look for where does y1 equal y2. And again, you can use calculator variables as long as you tell the reader that you've sort of renamed them. That way, this sort of switches it to your brain is thinking y1 and y2. You may as well put that on your paper. So 2t minus 1. And what am I looking for on the graph? Where they intersect. And they intersect right there. How do I get the calculator to find right there? Almost always second calc. Intersect. First curve, second curve. Guess just means kind of get close. Let the calculator think for a minute. So y1 equals y2 at t equals 1.571. If we want to be extra clear, at t equals 1.571, two particles have the same velocity. Man, I feel like that's one where a bunch of you could get all 9 points. Like you want to get one like that. If you can get a couple where you get all 9 points, you'd be doing really well. I mean, you know you're going to hit one or two that are just crazy, so you hope you hit a couple that are pretty straightforward like that. And this is one that's simple enough to follow along, and you can see why they ask all these questions. You had to take a derivative of velocity, you had to take an integral of the velocity, you had distance versus displacement, then you had to take derivative of position to get velocity. So they kind of ask all the motion questions you could ask in there. All right, I'm going to leave question 2 to you. I do want to point out part C. Is the speed increasing, decreasing, or neither at time 2? How do you know if speed is increasing or decreasing? Not velocity, but speed.
The acceleration and velocity are the same.
Same what? Yeah. So speed is increasing if they have the same sign. Speed is decreasing if they have different signs. So you would just find all the pieces you need to find with your calculator, and then just look at who's positive and who's negative. That's part of question 2 there. All right, let's look at 3, 4, 5. I leave question 2 for you to do. That's the only other free response question. 3 through 5, I don't think the AP test does this often, so I think this is just a review thing. But if you look at questions 3, 4, 5, they all have the same velocity, and they're just asking different questions. And so, especially on a calculator test, I'm probably just going to go ahead and put that in for velocity, or for y1, and then go from there. 1 minus inverse tangent of e to the x. They like to do crazy stuff when you have a calculator, because calculator can handle it. 1 minus inverse tangent of e to the x. T is greater than 0. Acceleration of the particle at time 2. Why don't you try number 3? I bet you can get number 3, and then we'll talk about number 4. So you try number 3. So dy dx at 2, negative 0.133. Hope your answer choice is there, and it is. So we're good. Number 4. Particle moves along the y-axis, so that its velocity is, okay, so same velocity. At what time does the particle reach its highest point? So what would be happening? So maybe it goes up and then it comes down. That would be where its highest point is. What's happening right there? How am I going to figure out when that is? When what changes? Okay, when you say f prime, I like that answer, when f prime changes. But use, instead of f prime, when f prime changes positive to negative, to be even more precise. But in the context of this problem, what's f prime? Is that... So here's where we need to be careful. Is that acceleration? I mean, acceleration is the derivative of velocity, that's true. But its highest point, think about what's happening. It's moving up, and then it's moving down. So that means its velocity is changing. So it's when s prime, or position prime, changes, which means when the velocity changes positive to negative. So be careful, it's not when the derivative changes positive to negative, which you would never get because it looks like the derivative is always negative. But there is a spot right there where velocity changes from positive to negative. So that's when it changes from going up to going down. So let's find that intersection. And remember, you get 3 minutes per question on the calculator questions. So it gives you a little time to type things in and play around with the calculator. Oops, what did I do wrong here? I need a 0. I think I hit something else. Left bound, right bound, enter. T equals 0.443. Again, no justification is required for multiple choice, but the idea is that's when velocity changes. Question 5, same initial setup. At time t, the particle is at y equals -1. So at time 0, y is -1. What is the position of the particle at time 2? So how do I find the position if I know the velocity? Integrate. So see if you can figure out number 5. It involves an integral, but it involves more than that by a little bit. So see if you can figure out number 5. So an integral 0 to 2, because those are the 2 times you're worried about. Move things around, use the calculator, -1.3. On the back, I want to look at number 9 and 10. That might be all we get to today. Number 9, a particle moves along the x-axis so that its velocity is given by that thing. Find the average speed. Average speed of the particle. Okay, how do I get from velocity to speed? Like, how are those related to each other? Pardon? No, the integral velocity would give me position. Velocity and speed are like really similar. It's related to the distance and displacement difference. It's absolute value. Speed is the absolute value of velocity. Right, that way it takes the sign off of it. We don't care about direction. We just want to know how fast we're going. And then the average value, that's 1 over b minus a, integral from a to b of whatever we want the average value of. And that's not really the velocity, it's instead the speed. So the absolute value of velocity. So from 0 to 5 would be 1 over 5, integral 0 to 5, absolute value of velocity, dt. So there's a couple things now you just go to the calculator and type everything in, but there's a couple things that problem is testing, like average value, you got to remember that formula, and the speed velocity difference. 1/5, Math 9, 0 to 5. Since there's not a lot of problems with this one, I'm going to straight type it in rather than using the y1, although you certainly could use y1. Absolute value, natural log x squared. And we've seen this a couple times. The more complicated the integral, the longer it takes the calculator to think through things and figure it out. 1.022. I hope that's an answer choice. Uh-oh. It is not. What did I do wrong? 1/5. Oh, I know what I did wrong. You see what I did wrong? I do need to read the question more carefully. So it gives me the equation for 0 to 5, and it wants the average speed from 0 to 2. So instead of going 1 to 5 or 0 to 5, I need to do 0 to 2. So I found the average speed, but from 0 to 5 rather than 0 to 2. It was kind of them to not make that one of the wrong answer choices. Let's see if this works better. 0.371. Yes, I like that better. Why don't you try, I had 10 marked for me to do, but I think we've talked about total distance versus displacement enough. Why don't you try number 10, and we'll see if we get the same thing. So this one's kind of a pain to type all the stuff in. Make sure you get everything positioned right. Also make sure you're always in radians, but 4.334 is my answer. All right, I will leave the rest for you to do.